understanding organic reactions. I'm I'm hesitating, but I'm going to do this anyway. Okay, I'm going to do this slightly differently because I want to present my views of how organic reactions work and stuff like that. So, we look at organic molecules or atoms as just, something that's on the paper, and it helps sometimes to give atoms some personality. Like, I don't know, since atoms are not personality, maybe we can call it atomality or something like that. Okay. And I saw this video and I thought that was a really cool video, and I'm hoping maybe I can share that with you. So let's see if I can share this. So when you think of atoms, you think of them as having this part in knowledge, science, doing all kinds of scans and stuff.
Can't get it now. I can't get it now, but I can get it. Can't get it now. I can't get it now, but I can get it. Walked up the stairs. Walked up the stairs. Can't get it now. I can't get it now. I can't get it now, 'cause the fuck is downstairs. I'm going to quit. The fuck is downstairs. I'm going to quit. I can't get it now. I can't get it. I can't get it now, but I can get it. Can't get it now. Can't get it now, but I can get it. Can't get it now, but I can get it. I walked up 2 flats. Walked up 2 flats. Walked up 2 flats. Stairs.
If you think of atoms having personality and interacting with each other, remember I just said it's all about relationships and how do they relate to each other. What do they think about molecules when they see a certain molecule? So if you think of that, then things become a lot easier. All right. So, chemical reaction, right? So, this is a generic reaction I wrote. I mean, you have this molecule and it reacts with this, and it simply displaces this one atom. So you can look at reactions as bond breaking and bond making. Some bonds are broken and some bonds are made. And if you ask yourself, what makes this bond break and why is another bond formed, you can pretty much have a better understanding of that, okay? So bond breaking always takes energy and bond making always gives out energy. And for all that, we need to understand what bonds are, okay? So if you have two elements, two atoms, okay, what happens is they have a nucleus and electron. This one has nucleus and electrons. Nucleus is positively charged. So the nucleus will repulse the other nucleus. There's a nuclear repulsion. Electrons repulse each other because they're both negatively charged. But these nucleus will be attracted to these electrons, and this nucleus is attracted to these electrons. So essentially, bonds have attractive forces and repulsive forces. So it's a interplay between attractive forces and repulsive forces. So we can think of a bond like a slinky, like a spring, one atom on the other side, one atom on the other side, and they're constantly moving. Okay, they're not just static. And the more energy you put, the more they move. And as they move, so this is the curve. Okay, so this is the distance between the two nuclei. and this is the energy, and this is their resting place. Okay, and as if you raise the temperature, they keep oscillating a little bit, and as the springs move further apart, the energy goes up because there's less attraction, and so the energy goes up. And after a certain distance, the one atom just doesn't see the other at all, and there's no bond. Bond is broken around this point. Okay, so you can raise the energy up and then make the atoms move further apart and the average distance. Okay, but if they move too close to each other, then these repulsive forces become greater, and the energy keeps going up. So too much intimacy between the two atoms is not a good thing. That's why you should keep your partner at a certain distance. Don't get too intimate, otherwise the energy will go up and you'll have all kinds of wars and fights. Unless, of course, it's your soulmate, and then everything is okay. All right. So that's how the atoms work. So now what happens is, I color coded this just to make it more interesting. Okay, this molecule is reacting with this molecule. Okay, so this greenish part is part of the molecule. This blue part is going to leave, and this white part will get attracted to this. So what happens is, here there are molecules A and B dancing away, going every which way they can, almost at a party. And then when that happens, A begins to notice C. This is a red guy, passionate guy. I like him. And so they begin to interact. C begins to interact with A. And as C begins to interact with A, B is beginning to sort of move away. A is looking at B and saying, he's a very stingy guy. He's not generous. Just imagine B being a very electronegative atom. Okay, it wants all the electrons for itself. It's not willing to share any electrons with A. But whereas C has got lots of electrons, and it's going to share with A. So A begins to believe that B is maybe not the right partner, and so B, it creates a distance between A and B. And as C moves along, they interact closer, and they become closer and closer, and B is moving away and away. And then finally there's a break, and B is gone. And now C is happily living ever after with A until they meet somebody else. So that's how the reactions go. So this curve here, okay, the first curve is for AB, okay? So here's the resting distance for AB, and in this way they get too close, and as they go along here, the bond becomes longer and longer. And this is the curve for AC, for this one, okay? So again, A and C, if they get too close, there's too much energy, and as the bond becomes longer, it's in the opposite direction. So this goes in this direction, this goes in this direction. In the opposite direction, the reaction, the energy becomes, the distance becomes longer and longer, and the energy goes up. So essentially, this AB is here, and this AC is here. So the path from going from AB to AC goes like this, okay? And this is a very important point. The highest energy is an important point where A is connected to B and C. So they're settling their arguments. A is having a lot of fights with B. And so there's a lot of energy, and C is sort of giving some support, but not all that much. And so this point here, where A is connected to both C and B, is here. And that's a very important point. It's called a transition point, okay? So that's how the reaction goes, okay? So that's my view of the reaction. Okay, we'll come to that later, okay? But the important part, sorry, did somebody have questions?
Yeah, why is the energy higher for more bonds?
Okay, so what happens is, this is one full bond. This is a very resting place, okay? And then as this thing increases, AB length begins to increase, and the energy goes up because they're far apart. And this is the AC bond, and it's long. It's longer than what it should be. So this is the resting place. And as this bond increases, that energy goes up. Okay. So this is the meeting place where energy for this and this are the highest. They are really higher. Once A decides to go with C, then it goes down. Okay.
Okay, so longer bonds are higher energy.
Yes, longer bonds are higher energy. Correct.
Thank you.
Okay. Yes. And this is a transition state. This is a very important place. And there was one person at a seminar who said, this is going to the court, to the judge to get married or something. That after that, it's all downhill. So I don't know. We'll figure that out.